We are starting the 7-2 lesson today, which is about factoring a difference of squares. So I'm hoping that the 7-1 lesson you know really well now since we spent like 3 days on it. So if you were not here yesterday, you are still responsible for the first 2 things on this list. And if you were goofing off yesterday, again, you're still responsible for the first 2 things on this list. The other 2 things were extra credit. So those extra credits, there's a link in Schoology that you can upload those to if you do work on them. But the first 2 things are worth points. The first thing was actually due Monday. I checked it on Monday, so if you didn't do it, you should have uploaded it to Schoology. But the second thing was a Google form. And the only way you lose points on that Google form is if you get like a low score on it, where I think you're guessing, or if you just don't do it. So don't just guess on it. Do use it as practice, because the first step for factoring is you should always look for a GCF first, and then we're going to look for the other methods of factoring today. So today is difference of squares. To be successful at that, you need to know what a difference of squares is. You need to be able to factor a difference of squares using that rule, which this rule I will not be providing to you. All right, I mean, I'm providing it to you for your notes, but I'm not really providing you anything on this coming up test as far as formulas go. So that's why you guys need to take good notes, since you can use notes on practically all of your tests. So that rule we'll talk about in a second. You need to also be able to factor a difference of squares when there's a GCF involved, and be able to check your answers by FOILing/distributing. I'm recording now, and I'll link it in the slides, just like I always do. Here's some other shorter videos that you might find helpful, so check those out if you feel like it. The practice is evens or odds, and so far my classes have had about like 15 minutes to work on it. I don't think I'll be checking it until Monday, because tomorrow and Friday we have benchmarks. So we'll talk more about how that's graded tomorrow. But the practice and exit ticket will be done on Monday, or as far as checking the practice and doing the exit ticket. So if you like finish early on the benchmark, you have extra time to work on this in class. Otherwise, get it done by the time you walk into class on Monday. So benchmarks tomorrow and Friday. Those are really just to see how much you've retained, and so that the district can see how much you've retained. And even though it's not something like we're supposed to prep you for, it is something that goes in the grade book. So it's just kind of seeing how much you should know. And given that we're like 75% through the school year, you should know about like 75% of the stuff on it. At least that's the theory. I'm only grading you on what we have already taught. So questions on anything? All right, so hopefully you finished the warm-up by now. Let's go over it. And these are from the last unit that we learned. So how would you solve these? Double distribute. And then what's that other method? Foiling. So for the warm-up, you had to either double distribute or foil. So double distribute, we'll do on the first one. What is x times x? And what is x times -4? And then distribute that 4 to the other parentheses. What's 4 times x? And it's positive, so make sure you put plus 4x, and 4 times -4. -16. Usually after distributing, you have to do what? So what are my like terms in this one? And what happens when I combine them? It equals 0. -4x plus 4x equals 0. They cancel out. So my final answer just ends up looking like this. X squared minus 16. All right, this next one we'll do by foiling. So first, outer, inner, last. multiply the first term in each parentheses. What's 5m times 5m? What's 5 times 5? Good, and then m times m is m squared. All right, and then multiply the outer term in each parentheses. So it's 5m times -1. Good, and then 5m times +1, positive 5m, and then multiply the last term in each parentheses. What's 1 times -1? -1. All right, are there any like terms I need to combine? Yes, the middle terms again. So it's -5m plus 5m. Cancels out, equals 0. So my final answer is 25m squared minus 1. All right, just one more. So again, we'll double distribute. What's 2a times 2a? And 2a times -3b. And then a times b would just be ab. All right, and then again, but now distributing the 3b. What's 3b times 2a? Good, and it's positive. And 3b times -3b. -9b squared. So that is what you get. What do you get after combining like terms? So do I have like terms? What do I get when I combine them? They cancel out. So then my final answer is what remains. So 4a squared minus 9b squared. Right, and then, so those are the answers for the warm-up. Questions on that? So that shouldn't be new to you. And then I'll talk about the answers here in a second. But do the middle terms always cancel out when you FOIL, like in any situation? No, but in this lesson they did. So our answer ends up being what's called a difference of squares when the middle terms cancel out after FOILing. And it's a difference of squares because what does difference mean in math? Subtraction. They all have subtraction signs between them. And then what do squares mean in math? And I'm not talking about the shape. What do squares mean? Multiplying by itself, how many times? Twice, so like an exponent of 2, essentially. So like x squared is a perfect square. 16 is a perfect square, because that's 4 squared. 25, another perfect square. M squared is a perfect square. Is 1 a perfect square? It is. Square root of 1 is 1. And then same with these, they're also perfect squares. So that kind of leads us into the lesson today, because our answers from the warm-up are going to be what our questions look like in this unit. And then our answers would be what we originally had. So from our answers, we're going to figure out what we multiplied to get them. All right, so first thing you have to do, here's some steps, is you need to make sure you have an actual difference of squares. So you need to have a minus sign. And you need to have perfect squares on each end. So again, it says must be a subtraction sign, and you must be able to square root both terms. Step 2 would be to use the following rule to factor, which you need to write down. So a squared minus b squared equals a plus b in parentheses times a minus b in parentheses. Because that's what this is over here, isn't it? It's the same exact 2 terms. It's just one has a plus and one has a minus. And then lastly, you can always check your work by distributing or doing what? or FOILing. All right, so now let's practice that. So number one, are these a difference of squares? Is there a minus sign between them? Is a squared a perfect square? Is 4 a perfect square? Then yes, and we can use the rule on that. So for difference, yeah, you'll have a subtraction sign, and then on each side of the subtraction sign would need to be a perfect square. All right, so what's the square root of a squared? What times what gives me a squared? So my square root would be a. The square root symbol basically cancels out any exponents of 2. So that means the first thing in my parentheses is going to be an a. The second thing will be whatever the square root of 4 is. What's the square root of 4? So then my parentheses look like this. A plus 2 times a minus 2. All right, because that follows this rule that we're given. And then if I were to FOIL or distribute, would I get the same thing I originally had? Then yes, I did it correctly. Try number 2 while I answer the phone. All right, so what would be the answer for n squared minus 64, you think? So are these a difference of squares? So is this a difference of squares, number 2? So difference means subtraction. Is there a subtraction sign between them? And are there perfect squares on each side of the subtraction sign? So then yes, so then we can apply this rule. So what's the square root of n squared? And what's the square root of 64? So my parentheses should look like this, n plus 8 times n minus 8. So you plug it in according to the rule. Questions about that? All right, if you're not sure if something's a perfect square, you can always use a calculator or Desmos. The square root button looks like this, kind of like a division sign with a little line there. If you need help finding it on a different calculator, I can help you. But if you get a decimal, it's not a perfect square. All right, now let's look at some others that are a little more challenging. So let's look at 6 together. Is this a difference of squares? Yes. So there's a minus sign. 1 is a perfect square. What's the square root of 1? And then this is also a perfect square. You'll just have to kind of break it up. Desmos will not solve variables for you. But what's the square root of 49? And what's the square root of y squared? So 1 plus 7y will be our first parentheses. 1 minus 7y will be our second. All right, and you can like put the minus here and the plus sign here. That doesn't really matter as long as they're different. All right, questions, comments, concerns? All right, you guys try 3, 5, and 7. All right, try these 3. All right, what was the answer for 3? So yes, 9 is the square root of 81, and then what? Plus x, good. And then your other parentheses would be the same thing, just with a minus sign. All right, now what about number 5? Is that a difference of squares? Why not? Good, so since it has a plus sign in the middle, that's not a difference of squares. So I cannot use the difference of squares rule on this one. Can I factor out anything else? Like, can I factor out a k or a number? I cannot, because they both don't have a k. And the coefficients are 1 and 25. There's no GCF other than 1. So number 5 would be prime. All right, if it's not a difference of squares and there's no GCF, then it's prime. All right, and then 7 was the last one I had you do. If you did it correctly, you should have had 3b minus 10 or plus 10. I'll keep it as plus so it looks more like the rule. And 3b minus 10. So questions on the front side. All right, so let's look at some on the back side, a little bit more challenging. So number 13, we'll look at first. Is this one a difference of squares? Yes, it has a minus sign and there's perfect squares on each side of the minus sign. So what's the square root of x squared y squared? xy. And what's the square root of 1? So then plug it into your rule, xy plus 1 and xy minus 1. And if I were to FOIL or distribute, I get what I originally had. So just more stuff in that one, just talented. Now let's look at 14 together. So this is a difference. Is it a difference of squares? Yes. And that n to the 4th, like if you thought no, is still a perfect square. All right, so when it's exponents on variables, think about what can I multiply together to get n to the 4th. So the square root of 81 is 9, thank you. But the square root of n to the 4th would be what? N squared. Because think about what times what would give me n to the 4th. Wouldn't n squared times n squared give me n to the 4th? Yes, and it has to be the same thing multiplied by itself. So if it's an exponent on a variable, and that exponent is even, so like 2, 4, 6, 8, 10, then yes, it's a perfect square. Just divide it by 2, and you get its square root. Make sense? And then what's the square root of 25? Good, so then your parentheses look like this, 9n squared plus 5, and 9n squared minus 5. Good there? All right, I feel like some of you didn't understand, so let's try again. Let's look at 19 together. Is this a difference of squares? Yes. What's the square root of 121? And what's the square root of r to the 6th? R to the 3rd. Good. And if you're not sure, test it out. R cubed times r cubed does give me r to the 6th. And then what's the square root of 1? So then I get 11r cubed plus 1 and 11r cubed minus 1. Good? All right, so then you try 15 and 17. All right, so 15, is that a difference of squares? So it is a difference of something, because it has a minus sign. Is 4c squared a perfect square? Is 5b squared a perfect square? All right, it's not. So if you put the square root of 5 in your calculator, it gives you a decimal, and there's nothing else I can factor out, like no GCF. So that means this one is prime. All right. 17. That one is a difference of squares. So what's the square root of k to the 6th? And what's the square root of 16? So then I get k cubed plus 4 times k cubed minus 4. So again, if it's an even exponent on a variable, just divide that by 2. That's your square root. Questions? All right, bear with me. This next part is a little more challenging, so like I need your full attention on this next part. All right, so examples with GCF. Really, like once you learn all the factoring methods, the first step should always be to check for a GCF first. So first step is always check for a GCF. Because if you just jumped into seeing if it's a difference of squares, then you might say that like this example is prime when it's not. All right, you can factor out a GCF, so it's not prime. So step one would be to check for a GCF. Step two would be to factor out the GCF. All right, so on 21, I have 2 and 72 are my coefficients. So what can I factor out between 2 and 72? What's my GCF? 2. So always check the smaller number. If it divides evenly into the other, that's your GCF. So that will go outside parentheses. Inside is what you get from dividing by your GCF. So what's 2n squared divided by 2? So the 2's cancel out to 1, and then all I have is n squared. And then what's negative 72 divided by 2? Negative 36. Don't be afraid to use a calculator. All right, but you divide out your GCF from both terms. That's how you get the parentheses. All right, step 3 will be to check your parentheses. So step 3, check your parentheses for a difference of squares. All right, check parentheses for a difference of squares. So is inside the parentheses a difference of squares? There is a minus sign. Is n squared a perfect square? Is 36 a perfect square? Yes. So my GCF will stay outside the parentheses, but now the parentheses can follow the difference of squares rule. So it'll be n plus 6 times n minus 6. Questions on 21? All right, then let's look at 24 together. So I have clearly not a difference of squares. 45 is not a perfect square. 20 is not a perfect square. So that gives you a good indication that I should check for a GCF. So what's the GCF between 45 and 20? 5 is correct. That's the biggest number that you can divide evenly into both. I could always make a factor tree if I'm not sure, but it is 5. Can I factor out any Q's? Yes, because they both have at least one Q. How many can I factor out? Just one. It's always the smaller exponent if it is present. All right, so that's my GCF. Questions on that part? All right, I'll do some scratch work over here. So inside parentheses is what you get from dividing the terms by your GCF. So I get 45 cubed divided by 5 cubed. What's 45 divided by 5? And q to the 3rd power divided by q. Good. And then the next term divided by your GCF. So what's negative 20 divided by 5? And q divided by q. Cancels out. So here's what I get for my parentheses. All right, step 3, you check for a difference of squares inside the parentheses. So do I have a difference of squares inside these parentheses? Yes, you have a minus sign and you have perfect squares on each end. So what's the square root of 9q squared? And what is the square root of 4? So then your parentheses follow the difference of squared rule. 3q plus 2 and 3q minus 2. Questions on those ones? All right, so then I'll give you a few to try. Try 23. And we'll go with 25. Actually 28. 23 and 28. So this is not a difference of squares, like 32 is not a perfect square, 18 is not a perfect square, so check for a GCF. What would the GCF be between 32 and 18? What's the biggest number that you can divide evenly into both of those? 2 is correct. All right, you can always do a factor tree just to make sure, but 2 is the biggest number that is possible to divide into both. Can I factor out an S from both? No, because they both do not have S's. Well, at least one of them does, but the other one doesn't. Can I factor out a U from both? All right, so my GCF is just the 2. So divide 2 from both of these. What's 32 S squared divided by 2? (16 S squared). What is negative 18 U squared divided by 2? Negative 9 U squared. All right, so check for a GCF, factor it out. Now you check for a difference of squares inside the parentheses. So is there a difference of squares in here? Yes, so use your difference of squares rules. What's the square root of 16s squared? And what's the square root of 9u squared? 3u. And then according to the rule, one parenthesis will have a plus sign, the other one will have a minus sign. So questions on 23. All right, then we have 28. And that will be the last one we do together unless you want to see some other ones. But 28 is not a difference of squares, at least not yet. What will the GCF be between 8 and 32? I have had people say 4 last hour, but there's a bigger one. So you want the greatest common factor, which is 8. So always check the smaller number and see if it divides evenly into the other one. Can I factor out an x from both? You cannot, because this one doesn't have an x. Can I factor out a y from both? How many? Just 1, because this one only has y for the first. All right, so that's the GCF. Divide it from each term inside. So 8x squared y divided by 8y. What happens when you have the same thing on top and bottom? Cancels out to 1. So the 8's cancel, the y's cancel. The x squared is all I have for the first term. Then divide it from the other term. So negative 32y cubed divided by 8y. Nothing cancels out here, but what's negative 32 divided by 8? Negative 4. What's y cubed divided by y? Y squared. All right. Now check if your parentheses have a difference of squares. Do they? Yes, it has a minus sign. It has perfect squares on each side. So what's the square root of x squared? What's the square root of 4? And the square root of y squared? Good. And then your other parentheses will look exactly the same, just with a minus sign. So questions on 28? Any others you want to see? All right. So that concludes our notes. I know it was long, but do make sure that when you work on your 7-2 practice that you do actually try the ones with DCF, because those will be meant to trick you on the test. So 7-2 practice, evens or odds, it gives you like 15 minutes. You can always check your answers as you go on the back wall.